Another interesting thing available in Android Studio is the graphics editor. It makes it possible to modify the layout without the need to write it from the level of the code. It's a very useful feature, particularly at the very beginning because it allows a simple definition of the layouts. It does not require much knowledge on the performance of particular components. To gain access to the graphics editor, we just need to start the XML file and switch from the tab Text to Design. This way, we obtain access to the graphics editor. We have an entire collection of views at our disposal. Additionally, we have the view hierarchy and the properties of the particular components which are currently marked. For instance, we can drag the linear layout to the device screen, place it somewhere in the middle, and put two buttons inside it. If we want to change the layout orientation, we don't have to remove it, we simply change its properties. All the things which can be defined in an XML file can be set in the graphic editor using a mouse. The editor is intelligent, so in case of magnifying elements, its size is determined using a DP unit. But if the editor notices that I mean the entire width, the match parent value is automatically assumed. A good thing about the editor is that the generated code is extremely readable. It looks as if it was handwritten. Because of this, we can use it interchangeably. We can write a code fragment using the editor and then switch to the second mode to edit it. In most cases, more experienced programmers work on a text file with a preview, which makes it possible to immediately check what the layout will look like at a specific moment. A good thing in Android Studio in terms of the preview is that we have the possibility of an instant preview on another device. We can also change the device orientation, meaning its graphical style. There is a very interesting option called Preview Representative Sample, which shows us the preview on several views which represent very different configurations. Thanks to this, we can check what our view will behave like between very different locations. We can also choose the option Preview All Screen Sizes, which means that we'll receive a large collection of views for extremely large devices. Now, let's assume that we'd like to react to the click of one of the buttons from the level of the code. The simplest approach to handling clicks is using the onCreate method in the layout. Inside our button, we add the handling of the onClick event, providing the name of the method which will be called as the click of the first button. Let's call our method, for instance, clicked. Right away, we get an information that the method is not present in the activity or its signature is not correct. This allows the quick generation of the missing method. We get a special method with the signature public void clicked, which takes view as a parameter. It's very important because every view may be clicked. Due to this, the method which handles clicks has to take each view type. After clicking the button, we may react in a specific way. The simplest solution will be to move the code responsible for starting the new activity to handling buttons. Now, after clicking the button, a new activity appears. It's a very simple and quick method, but it has one basic flaw. If we want to use a certain layout a number of times, we need to define a new method for each activity. If we forget about it, we'll receive an exception and the application will stop working. That's why it's a better approach to add click handling from the level of the Java code. Instead of defining it in an XML file, we'd like to define what is supposed to happen after the button is clicked inside the activity. In order to perform something like that, we must have access to the button. Given that we have two buttons, we must recognize which one has been clicked. That's why we assign an ID to each button. In case of ID fields, the notation is as follows: @ plus ID slash any underscore name. Once we have a specific ID, we may access a specific button. In order to get a reference to the object which represents our view, we have to call the findViewById method. It takes only one parameter, that is, the object ID. As I've already mentioned, our ID informs that we want to access a particular ID. In our case, it'll be the ID button. Such a call will return us the view which is present under the provided ID. In this case, the findViewById method is connected to the setContentView method. If the result of the method operation is assigned to a button, a certain problem arises. The method returns a view, and we expect a button. The simplest solution of this problem is casting to button. Taking the advantage of the fact that we already have a button, we can call the setOnClickListener method on it and pass the onClickListener implementation. In the simplest case, we can pass an anonymous implementation, which creates the onClick method right away. A new method may include any code or a call of another method. The onClick method has practically the same signature, meaning it is a public void and also takes a view. Now, once the button is clicked, a new activity appears. The problem with this approach is that in case we wanted to create another button, we'd have to create the onClick method again. This is problematic because a lot of the generated code appears in the form of anonymous classes. That is why the more common solution in Android is using one class which implements the listener and, depending on which button is called, reacts with various methods. A quite often used approach is the implementation of the onClick listener interface to the view in our activity. In such cases, we don't have to create anonymous classes. This way, we can handle both buttons. For the time being, the same code will be called in both cases. To be able to distinguish clicks, usually we use the switch instruction, which operates on view get ID, meaning the number returned by the findViewById method. In case sections, depending on the button ID, the relevant instructions will be performed. Thanks to this, we have one method which reacts differently depending on which button has been pressed. It's not an ideal solution, but it's fairly often used in Android because usually in an activity, we have multiple buttons and views which should react to clicking.